In this video, we will be looking at using the properties of parallelograms. So here are the 5 properties of parallelograms. So the first one is that the opposite sides are parallel. That's the definition of what a parallelogram is it's a 4-sided figure where both sets of opposite sides are parallel. So if you remember, the marking for parallel is putting the little arrows on the side. So one arrow would be parallel to one arrow and then 2 to 2. So the tops are parallel and the bottom. So 2 pairs of parallel sides. Then we actually also know that the opposite sides are congruent as well. Okay, so this side is actually congruent to this side, meaning the same length, and this side is congruent to this side as well. So if this AB was 5, CD would be 5. If BC was 7.3, then AD would also be 7.3. Not only are opposite sides congruent, but the opposite angles are congruent as well. So angles across from each other. So angle A is congruent to angle C. And then angle B is congruent to angle D. So the ones across from each other are congruent to each other. Then the ones that are next to each other, so adjacent to each other or consecutive, they're sometimes called, those are going to be supplementary, meaning that they're going to add up to 180. And again, this is because they're same side interior angles. So if you go back to our unit on parallel lines, if this line is parallel to this line, then you have this transversal. These two are same side interior angles, meaning they total 180. Okay, and it's hard to mark that on the diagram, so I'm just going to write next to this that any 2 angles next to each other, so I'll just put blanks, and they are going to total up to 180. So this could be A plus B, it could be B plus C, it could be C plus D, or A plus D. So any 2 right next to each other will always total 180. Then we also have, if we were to draw in diagonals, okay, so diagonals are going to connect opposite vertices. So if I were to draw in these diagonals, and actually let me change their color. So if I was going to do this one, let's make this one orange, and then this one, what color haven't I used? Okay, so what's going to happen here is that the orange one is going to be split evenly, okay? So bisect means splits equally. So these 2 orange pieces, or these 2 orange parts, are going to be equal. So this one is equal to this one. And then also on the other diagonal, this chunk is equal to this chunk. So if this were 2, this would be 2. If this was 1.3, this would be 1.3. So the diagonal itself is split up evenly. They aren't equal to each other, okay, but they, like, the orange isn't equal to the pink, but the pink is split up and the orange is split up. All right, then let's go ahead and use some of these properties. So one thing I do is think about it as there's properties about sides, there's properties about angles, and then there's properties about diagonals. Okay, so when you're looking at a diagram, I would figure out, does this diagram have sides, does it have angles, or does it have diagonals labeled? So in this case, we have the 2x plus 15 is on this side, ST, and then the x plus 15 is on this side. So we actually have sides. So if we go back to our properties, we're looking at sides. So do we have opposite sides that are parallel, or are we looking at opposite sides congruent? Okay, so we have opposite sides. Parallel doesn't do us any good. So we'd be doing congruent. So we know that those are congruent, which means that we will set them equal to each other. So the property being used is that opposite, and I'm just going to abbreviate that. So opposite sides are congruent. So now we have an equation. Now we'll solve it. So I'm going to get the x's on the same side right away. So I'm going to subtract 1x from both sides. So then I get x. So 2 minus 1 is 1x. 15 equals, and this is 0, and this is 15. So get x by itself, we're going to subtract 15 from both sides. So we just have x, this will be 0, equals 0. Which kind of feels weird that we would have 0, but if you plug it in, if you plug in 0 here, okay, 2 times 0 is 0, so this side is 15. 0 plus 15 is 15, so both sides are 15, so that's good. Okay, then looking at this one, so we want to decide, do we have sides, angles, or diagonals? So in this case, we have angles. Okay, so if I look at my two properties dealing with angles, that's these two. Okay, do I have opposite angles or adjacent angles? So are my angles across from each other or next to each other? And in this case, we have opposite angles. Okay, so what that property said is that opposite angles are equal to each other. So this angle G is going to be equal to E. So we would say 5x minus 9 equals 3x plus 11, and then solve. So again, I like to get the x's together first, so I'm going to subtract 3x from both sides. So 5x minus 3x is 2x. We still have this negative 9. 3x minus 3x is 0, so we're left with the 11. Get x by itself by adding 9 to both sides. So we have 2x, this is 0, equals 20. 2 times x, so we're going to divide by 2. 2 divided by 2 is just 1, so we have 1x. 20 divided by 2 is 10. So then again, I would plug it in just to make sure that you get equal measures here. So 5 times 10 is 50, minus 9 gives you 41 for that angle. 3 times 10 is 30, plus 11, you get 41 for that angle. So you do get equal angles there. All right, next one. So do I have sides, angles, or diagonals? This time we have angles again. Now these two angles are next to each other. Okay, so this one is that we have adjacent angles and they equal 180 degrees instead of each other. So now we're going to add these two together to equal 180 degrees. So this time we have some like terms to add over here before we get started. So we have just the 11x, and then 80 minus 10 is 70, and then equals 180. So then we have the 70 here, that's a like term with 80, so we'll bring 70 over by minusing 70 from both sides. So we get 11x equals 110. Divide by 11 to get x by itself, and we will get x equals 10. So then again, I would plug it in. This one's already 80, so I would plug 10 in here, so that's 110 minus 10, which is 100, and 100 plus 80 is the 180 that we wanted, so we are good. This problem, sides, angles, or diagonals. So in this case, we have the diagonals. So if we remember what the property said about diagonals, it says that they bisect each other, which means that they are equal to each other. So we've got this piece is equal to this piece. So 8 times the quantity x minus 1 equals 2x plus 4. And this is because diagonals equal each other. So in this one, you've got a parenthesis here, so we would want to distribute this before we start anything else. So then we'll get 8x minus 8 equals 2x plus 4. No like terms on either side, so we want to combine the like terms across sides. So I want to bring this, I like to do the x's first, so I'm going to subtract 2x from both sides. 8x minus 2x is 6x, we still have that negative 8. 2x minus 2x is 0, so we just have that 4. Then I need to get this negative 8 over with the 4, so we're going to add 8 to both sides. So then we have 6x, negative 8 plus 8 is 0, so just the 6x. 4 plus 8 is 12. And then we will divide both sides by 6 to get x by itself. Since 6 divided by 6 is 1, so 1x, and 12 divided by 6 is 2. Then again, let's plug it in. Okay, so if you plug in 2 here, you get 2 minus 1, which is 1. 8 times 1 is 8. 2 times 2 is 4, plus 4 is 8, so that is good. All right, so those ones we already knew that it was a parallelogram because they gave us the opposite sides were parallel. So these next couple examples, we're going to be trying to determine if, in fact, it is a parallelogram with the given information. So now we have to look at the diagram and see if one of the properties is happening. So again, ask yourself sides, angles, or diagonals. So we're given angles here. Okay, so now you want to check that opposite angles are congruent and that adjacent angles are supplementary. Another thing that you know about quadrilaterals is that they always total 360. So if we take a look here, we've got these opposite angles equal 110. These opposite angles equal 70. So that is good. Also, one other thing to check is that 110 plus 70 is actually equal to 180. So that you make sure that you have the right total, and it is. 110 plus 70 is. So you can write in here, it depends on what you looked at. Did you look at consecutive angles being supplementary, or did you look at opposite angles being congruent? I would say opposite angles are congruent. So this makes it a parallelogram, okay? Because 110 equals 110, right? And 70 equals 70, so we had that. It needs to be both pairs, so you can't just have one, it has to be both. Next one, do we have sides, angles, or diagonals here? Okay, and this time we have diagonals. So remember that the property that we're looking for is that diagonals bisect each other, okay, which means that they're equal to each other. So when we take a look at this diagonal, we're trying to see, is this piece over here equal to this piece over here? And it's not. So this cannot be a parallelogram, okay? Because 3.6 does not equal 3.8. So diagonals are not equal. Okay, so take a look at this one. So do we have sides, angles, or diagonals? So this one we actually have angles, and this one is going to go back to the chapter where we looked at parallel lines. So if you take a look at this angle that's given to you, okay, it's congruent to this one over here, right? The 2 marks. So you actually see that Z, so those two are alternate interior angles. That makes this line parallel to this line. Okay, so we get this one is parallel to this one. Then if you see, we have another set of angles equal. So we've got this one is equal to this one. So we've got this Z happening again. That's going to mean that this top green line and this bottom green line are also parallel. So we're going to get this one is parallel to this one. So we're actually looking at the opposite sides being parallel. And we do see that both pairs are. So we get both sets. Okay, so because both pairs of opposite sides are parallel. Next one, we see the diagonals are marked up. So remember, we're looking at the property that talks about diagonals bisecting each other or being equal to each other. So look along along this diagonal, we see that it's split into 2 equal pieces, so that's good. One of the diagonals is bisected. So let's take a look at the other one, and we see that this piece is marked congruent to this piece. So both diagonals are being bisected. So we would say yes. Why? Because both diagonals are bisected. Okay, last 2 problems here. Again, seeing if they're parallelograms. So let's take a look at this one. So we see a bunch of angles given to us. We see one set is marked as congruent, but one set of opposite, but we need to check the other one. Okay, so there's a couple things you could do here. Since you don't have both pairs of opposite given, okay, you could say, well, actually, then I want to look at consecutive angles or adjacent angles, and you could compare these. Okay, so adjacent angles need to equal 180. Does that equal 180? No. Okay, so then you would say that this cannot be a parallelogram because 60 plus 140 does not equal 180. You have to have consecutive angles being equal to 180 in order to have a parallelogram. Another option would be to take the interior sum of a quadrilateral, which is 360, and subtract all of these off. So you could subtract 140, subtract 60, subtract 140 to find this missing angle. So if you did that, let's see, that's 140, 200, 340. So 360 minus that is going to be 20. And then if you did that, you could say, well, opposite angles aren't congruent because you only had one set. So you got a couple options you could do there. This one, so again, remember, we don't know if it's a parallelogram yet, so we're trying to figure it out. Okay, so we have to go based on a true statement from here. So I can see that this side is marked congruent to this side, which is beneficial because then I can figure out how big x is so that I know if these two sides are congruent. Because remember, for a parallelogram, you need both pairs of opposite sides to be congruent. So let's solve for x, okay, by setting those equal to each other since they're marked. So then you can subtract 2 from both sides. So you get 3x equals 18, divide by 3, and you get x equals 6. So now you can go ahead. So if you plug 6 in here, you're going to get 20, right? Because that's what you just solved for. So 18 plus 2 is 20. So we for sure see those two sides are congruent. Then you can plug it in here and see that now you can tell that this side is congruent to this side. So you're analyzing that both pairs of opposite sides are congruent, okay? And so you set those two that were marked up equal, you solved and found out that yes, both pairs. So you found out that both sets are equal, which makes it a parallelogram.